Thank you for joining this lesson. We're going to discuss mathematics, paper 2, and mostly we will be covering a section 1, specifically Form 3 work. As we continue learning, remember our program here, whereby you can access airtime of any amount for any network. Airtel, Telcom, Safaricom, just go to your M-Pesa, Lipa na M-Pesa. The pay bill number is 737356. Then the account number is your own phone number. The account number is your own phone number or that of a friend. If you want to purchase airtime for a friend, you just enter their own phone number as the account. Then from there now, you'll be able to access any amount of airtime and it is going to reflect instantly. So thank you so much for joining us. You can share this broadcast with friends. Let them also benefit. You can comment as we continue learning. Let us know where you are following us from. Remember our consultation line 0704153366. So through this number, you can organize for individual institutions. You can also organize for anything else. You can request revision materials and we will be here to sort you out. Look at number 1. Without using mathematical tables or calculator, express root 24 divided by 2 plus the tan of 840 degrees in SURD form, and then simplify this particular SURD. Yeah, so what you're supposed to know is that this is trigonometry 2 blended with SURDS. And we are going to handle the concept on angles greater than 360. So there is always an acute angle which can represent a bigger angle greater than 360. So we will look at which is this acute angle that can substitute 840. So when we draw the unit circle, for example, look at this. It's the unit circle. This is the unit circle. You know, this one is the first, the second, the third, and the fourth quadrant. So in the first cycle, that is 360. If we continue, after a complete cycle again, it will be 740. But now the angle is 840, which means more is remaining. We have to continue and include even 120 degrees more. So when we add 90 to 720, this is going to be 810, which means 30 is remaining. So we add 30 at this point. Add 30 at this point. Now you discover that the 30 we have added there cannot be considered because it is being measured from the y axis. We always measure angles from the x axis. And so we will say that now 840 degrees is the same as an acute angle of 60 degrees in the second quadrant. So the quadrant where it lies is equally important. 60 degrees in the second quadrant. So how are the trigonometric ratios in the second quadrant? In the second quadrant, we're supposed to know that tangents are negative. It is only signs which are positive there. Therefore, the tangent will be negative. So now when we talk about 60, the trigonometric ratios of 60 can be expressed in SURD form when you consider this. Sure, this one now is going to be a bit longer, but students are supposed to understand what we are doing. If we come up with an equilateral triangle of side 1, 1, 1, then we bisect this such that this now becomes 60. It was 60. So we make it now 30. Then we have 60 at this point. The other one is automatically 90. This one now becomes a half and half because the whole length was 1. So the trigonometric, okay, the height can be expressed. And how do we get height? A half squared minus 1 squared hypotenuse minus half squared the square root. So it will be 1 minus a quarter, which becomes 3/4. So we want the square root of 3/4. The square root of 3/4. Remember, the square root of 3 can be expressed, but that of 4 becomes 2. So we can simplify it to that level. According to the height here now, it will be √3 out of 2, √3 over 2. So when we talk about tan 60, when we talk about from this diagram now, the tan of 60 will be the opposite length, which is over 2 divided by the adjacent length, which is half. So we will talk about √2, √3 over 2 multiplied by 2 over 1, which is √3. So the tan of 60 is usually √3. But now, being in the second quadrant, it's going to be negative. Therefore, substituting it in the expression up there, it will become, let me use the space here, it will become the root of 24 out of 2. Instead of plus, the root of 3 now becomes negative, because the tan of 840 is a negative, because 840 lies in the second quadrant where the tangents are negative. All right, so now we can now simplify, whereby we simplify by rationalizing the denominator. To rationalize the denominator, and also we can, as we rationalize the denominator, simplify the numerator. In the numerator, the root of 24 can also be put as the root of 4/6, yeah, divided by 2 minus the root of 3 multiplied by 2 plus the root of 3. And now the 2 plus the root of 3 introduced multiplies also the numerator. It's called the conjugate of the denominator. But now when we examine the denominator, we should be able to notice something, that it's just a difference of 2 squares which has been factorized. So we expand it the way we are supposed to expand a difference of 2 squares. So from simplifying the initial numerator, this becomes a 2 by √6. 2, 6. Then now we are having 2 plus the root of 3 divided by, so the denominator we've said it's a difference of 2 squares, whereby now we're supposed to expand it such that we take 2 squared minus √6 squared. So it will be 4 minus 3, which is just 1. Yeah, 4 minus 3, which is just 1. 4 minus 3, which is 1. All right, from the numerator now we open brackets. Yeah, to open brackets means 2 √6 by 2, it becomes 4 √6. 2 √6 by √3, it becomes 2 the root of 18. Yeah, 2 the root of 18. Now at that point now, we can simplify further. Simplifying further means 4 √6 plus, this will be 2 and the root of 9 by 2, because the root of 9 is known. So we shall be talking about 4 root 6 plus 2 times the root of 9 is 3. So that becomes 6. Then we have remained now with only root 2. And remember, okay, it's already simplified, but it is good you know that this can still be simplified further. Simplified further in which way? Simplified further in the manner that we can take 2 out, which is common. So that will remain with 2 root 6, then 3, the root of 2. Yeah, it's now fully simplified. Fully simplified. So that is how we handle that number 1. It's really an involving question, and it's good for learners to understand. Look at number 2 now, which is on errors and approximations. The sides of a rectangle are given as 4.5 centimeters and 2.5 centimeters. Calculate the percentage error in its area, the rectangle's area. The first thing we're going to do here is to identify the limits within which the dimensions have been recorded. Looking at 4.5, and 2.5, they have both been recorded to the nearest 1 decimal place. And if it is nearest 1 decimal place, it means the smallest unit, or rather the accuracy of recording this. The accuracy being 1 decimal place is 0.1. Because if we are recording 4.5, it means we can go to 4.6, 4.7, 4.8 that way. If we are recording 2.5, it means there was a 2.4, 2.6, 2.7 in such a manner. So the accuracy in both dimensions is 0.1. Now, how do we get absolute error in the recording of dimensions? Absolute error is given by accuracy divided by 2. Accuracy divided by 2. Accuracy divided by 2 gives us absolute error in the recording of dimensions. Remember, there is absolute error in the recording of dimensions, and there is also absolute error in computations. So we are beginning with absolute error in the recording. So the absolute error when we record a certain value to an accuracy of 0.1, then is 0.05. Now with this accuracy now, with this, we can get the limits. So the length shall be lying between, when we take 4.5, we subtract or add 0.05. So this means that the length will be lying between 4.45 when we subtract centimeters and 4.55 centimeters. That is now the limits of the length. What about the limits of the width? The limits of the width, which is 2.5, when we add or subtract the same absolute error, the same absolute error, because they have been recorded to the same accuracy. Then we shall talk about 2.45 centimeters to 2.55 centimeters. Now, with the limits within which the dimensions have been recorded, ladies and gentlemen, we can proceed to calculate something that we call maximum area. Let me call it area max, which will be given by the upper limits multiplied. Remember, being a rectangle, we just need length times width. So for area maximum, we need the maximum length multiplied by maximum width. This gives us, let me multiply it, 4 by 55 multiplied by 2.55. This will be 11.6025 square centimeters. Something else that we're supposed to know is that we can also calculate area minimum by taking the lower limits multiplied, 4.45 multiplied by 2.45, and this gives us, okay, let me express it first, 4.45 multiplied by 2.45, this will give us 10.9025 square centimeters. Then there is what we call actual area. Actual area or working area. This is the area when we use all the dimensions just as they have been recorded. 4.5 by 2.5. 4.5 by 2.5, giving us 11.25 square centimeters. 11.25 square centimeters. Something else that we're supposed to proceed with now, after we've gotten maximum area, minimum area, then the actual area, we need to talk about absolute error in the recording of these dimensions. Absolute error in the recording of these dimensions. We need area maximum minus area minimum divided by 2. 11.6025 minus 10.9025. Then we divide by 2. That gives us absolute error. 11.6025 minus 10.9025. Then we divide this by 2. I'm getting 0.35. In other words, getting absolute error, which has been involved in the computation, because we are having maximum and minimum, it's like a reverse process of the absolute error in the recording, whereby in the recording we began by the absolute error, then we went to the lower and upper limits of the dimensions. Assuming that we had been given the upper limit of the length and the lower limit of the length, how would we have obtained the absolute error? We would have just subtracted the 2, then divide by 2. Yeah, we subtract and divide by 2. After absolute error, we go to relative error, which is given by absolute error out of actual area. This is the relative error. And finally, the percentage error, which is given by relative error multiplied by 100. So now we multiply this by 100. And this becomes 3.11. 3.11. 1 is recurring. So an accuracy of 4 significant figures is okay, which can also be put as the accurate value, 3 and 1 over 9%. 3 and 1 over 9%. So that is the question on errors. Look at number 3, which is a question on logarithms. Yeah, logarithmic equations. Solve for x in the equation. Logarithm of 5x plus 75 minus 2, the log of 3, equals to the logarithm of 2x minus 9. Remember the law of logarithm that says if we have n, the log of a, this is solved by taking the log of a and we raise it to power n. So applying that at the second point here, which means we can write this logarithmic expression as the log of 5x plus 75 minus the logarithm of 3 power 2. So 2 becomes the power at this point, 3 power 2. So 3 power 2, which is 9, equals to the log 2x minus 9. 2x minus 9. Now, at this point, we can move to the second law of logarithms, which says that if we have the log of a minus the log of b, as long as they are to the same base, then this is solved by log a divided by b. If that is so, then we can say that we need logarithm, going back to the expression now, of 5x minus, okay, plus 75 divided by 9 equals to the logarithm of 2x minus 9. 2x minus 9. Now that we have fully applied the laws of logarithms that we would have applied in this particular equation, we can drop logarithms and equate 5x plus 75 divided by 9 equals to 2x minus 9. Cross multiplication will give us 5x plus 75 being equal to 18x minus 81. Yeah, minus 81, because 9 multiplies everything there. So when we group terms together, 18 minus 5 will be 13x. But now we have to take 75 plus 81, giving us 156. Yeah, 156. So that will remain with x. We divide through by 13. This gives us exactly 12. Exactly 12. So that is how we work out that simple logarithmic equation. Remember, our consultation line is 0704153366. It is also our M-Pesa line. You can use the same line to appreciate the work in shifting grades. Look at number 4, a simple question on making subject of a formula, just changing the subject of a formula. When the formula is written the way it is, the subject is E, and P is somewhere inside the variables which are used in the formula. You can see it is even applying twice. Now we are supposed to play along with these expressions until we make P the subject. Because of the square root sign, what we're supposed to do here is to square both sides first. When we square both sides of this equation, we shall get E squared. But now the right-hand side becomes P minus 3U out of Y minus 3XP. A cross multiplication will give us E squared Y minus 3 E squared XP equals to P minus 3U. Have cross multiplied, or rather multiplied both sides by Y minus 3XP, so that it simplifies from the right hand side, and the left hand side now E multiplies everything, so that Y is multiplied by E squared, and 3XP is also multiplied by E squared. That is what we get. The other thing we do here is we group the terms with P together. The terms with P are grouped together. So for us to group the terms with P together, the ones without P will also automatically be found to the same side. So let me begin by having E squared Y, and negative 3E now becomes positive 3U. That is equals to P, and what was minus here now becomes positive to the right-hand side. 3 E squared XP. So that at this point, P is factored out. We remain with 1 plus 3 E squared X equals to E squared Y plus 3U. At this point now, to remain with P, now we're supposed to divide through such that E squared Y plus 3U is divided by 1 plus 3 e squared x. 3 e squared x. So that is now how we are supposed to make P the subject of the formulae. Remember also our mode of acquiring airtime for all networks that operate in Kenya. Safaricom, Airtel, Telcom, just go to your M-Pesa, Lipa na M-Pesa, the paybill number is displayed here, 7356. The number is displayed here. You can actually memorize it. Share this with your friends. Then now once you've entered the paybill number, you go to the account number, which is now your phone number. The phone number now, whether for Airtel, Telcom, Safaricom, then after that, now you confirm your transaction and airtime is going to reflect instantly. Good. Number 5, remember to subscribe to this platform. Remember to share this link with a friend. Imagine this platform. Imagine yourself now, you got some friends somewhere and you are enjoying the platform and they are not aware about all this. Please invite them. Please invite them. I want us to be more in our next live broadcast. So please don't be joining alone. Learn to invite good friends. There's this great guy, Martin Luther King Jr., who said that we should learn to live together as brothers or perish together as fools. So let us prosper together. Let us grow together. Invite friends and family so that they may also learn, so that they may also acquire airtime through the paybill 737356. Number 5, solve the simultaneous equation 3x minus y equivalent to 9, x squared minus xy equals to 4. Yeah, from this, we cannot use elimination method because the powers of x are different. We can rush to what we call the elimination, the substitution method, whereby if this is 1, this is 2. Now, equation 1 can be expressed such that we make y the subject. And to make y the subject, we can take it to the right where it becomes positive. Then we have 3x minus 9. Yeah, 3x minus 9 now, because there is 3x here, and when we take 9 to the left, it becomes negative. But y taken to the right, it will become positive that way. So this is equation 1. Now, equation 2, instead of y, we can use 3x minus 9. So x squared minus x multiplied by y, which is 3x minus 9, equivalent to 4. X squared minus 3x squared. All right? Yeah, 3x squared minus, this now becomes positive, 9x equivalent to 4. I can see the equation is becoming quadratic. We have x squared minus 3x. So negative 2x squared plus 9x equals to 4. And this equation now we can arrange it in the right format. Ax squared plus by plus bx, plus a constant equals to 0. So the general format of a quadratic equation. So we can start with 2x squared, which becomes positive on the other side, but 9x becomes negative. Then 4 is already on that side, and it's positive. Then the whole of the left-hand side becomes negative. It becomes a 0. It becomes a 0. So to remain with a 0 on this side, we take all the terms to the other side, whereby we begin with 2x becoming positive squared, negative 9x, and 4 is already on that side. Yeah, I hope we are together in that grouping of the terms. So the equation is here. It's quadratic. Yeah, it's quadratic, and we are supposed to solve it now. We're supposed to solve it. It's my hope that the brackets have been opened correctly. There are many methods that we can use to solve quadratic equations. One of them being the completing square method, another one being the factorization method, and we also have the quadratic formula. Allow me use the completing square method, whereby I divide through by 2 first, so that this becomes x squared minus 9 over 2x plus 2 equals to 0. Yeah. Then now we take the constant to the right. X squared minus 9 over 2x equals to negative 2. When 2 is taken to the right, it becomes negative. So we shall add a constant here and also add a constant to the right, such that the constant is given by b over 2 squared. And remember, this constant is brought in so that it makes the left-hand side a perfect square. So how do we get this constant? Negative 9 over 2 divided by 2, then we square. And this is going to be 9 over 4 squared. 9 over 4 squared, 81 over 16. 81 over 16. So it will be x squared minus 9 over 2x plus 81 over 16 equals to negative 2 plus 81 over 16. Yeah. At this point now, we can talk of factorizing the left-hand side, which is a perfect square. To factorize a perfect square, we need x, then minus the sign which follows, minus the square root of the constant, which is 9 over 4 squared equals to negative 2 plus 81 over 16, 3 and 1 over 16. 3 and 1 over 16, which can also be 49 over 16. Yeah, 49 over 16. So we take square root of both sides. X minus 9 over 4 equals to square root of the other side will be plus or minus. When you take square root of the answer, I'm getting a 1 and 3/4. 1 and 3/4. 1 and 3/4. So how do I get values of x, which are 2? I start with 1 and 3/4 plus 9 over 4, or negative 1 and 3/4 plus 9 over 4. Yeah, plus 9 out of 4. So at this point now, x equals to, the first case I'm getting 4, or x equals to, when I'm having negative 1.75 plus 9 over 4, then I'm getting 0.5, or simply a half. So I'm having 2 values of x, which means I can get 2 values of y. The 2 values of y will be given by, remember this, y is given by 3x minus 9. So when x is 4, y shall be 3x minus 9. 3x minus 9. 3x becomes 12 minus 9, which is 3. When x is a half, 0.5, the value of y shall be 3x minus 9. 3x minus 9. I'm getting negative 7.5. So we have each value of y and the corresponding value of x, value of y, corresponding value of x. So that is how number 5 was supposed to be done. I'm using a lot of space because I'm doing serious elaborations. I've also gone for the completing square method because I know some students think it is a difficult approach, but it is very simple. So I wanted to show students that even when it is optional to choose a method of solving a quadratic equation, you can even rush to the completing square method, which is really interesting and approachable. Yeah, that is it. We talk about number 6 now. Given that C varies partly as A and partly as the square of A, and that C equals to 20 when A equals to 2, and C again equals to 21 when A equals to 3, determine the value of C when A equals to 4. So this is called a partial variation, whereby you encounter the word partly. You encounter the word partly, and that is it. So now we are supposed to write an equation or an expression relating C and A, and we are going to introduce two constants. Look at this. C varies partly as A. So C varies partly as A and partly, so we add as the square of A. Square of A. Students are also supposed to be very careful when interpreting that part. Some of them will see square of A and they will end up writing the square root of A. They will end up writing something like this, which is really wrong. So read the question carefully. Square of A means A squared. Now look at this. We can write C equals to, we introduce two constants, a constant in the first part and a constant in the other part. So the first constant can even be K, A, plus another constant, which can even be T multiplied by A squared. Yeah. So now with this is the general now equation. General equation. We will come back and get the specific equation. We are given that C equals to 20 when A is 2. C equals to 20 when A is 2. So this will be 2K plus A squared for T. That is one equation. Again, we are told that C equals to 21 when A is 3. We have two equations now. With two equations, we can solve them simultaneously. So from equation 1, I see that we can make K the subject. 2K becomes 20 minus 40. So that K becomes 10 minus 2T. Yeah. K becomes 10 minus 2T. So that when this is now substituted in equation 2 will become 21 equals to, instead of K, 3 into 10 minus 2T plus 9T. 21 is equivalent to 30 minus 60 plus 9T. This will be 3T. And on the other side, I'll be having 21 minus 30, giving me negative 9. So that the value of T becomes negative 3. If the value of T is negative 3, then the value of K can be gotten. The value of K will be 10 minus 2 into T, which is negative 3. So K becomes 10 minus 2 into negative 3. This gives us 16. Yeah, because negative becomes positive. Now, with these two values of constants, we can say that the general equation here, the general equation at this point now becomes C equals to K, which is 16, the value of A, then negative 3, which is the value of T, A squared. This is now the specific equation connecting C and A. Determine the value of C when A is 4. C equals to 16 into 4 minus 3 into 4 squared. So the value of C now has to become 16 into 4 minus 3 into 4 squared, which is 16. I'm getting exactly 16. I'm getting exactly 16. So that is how you're supposed to answer a question like number 6, which is very simple. Number 7, which is a trigonometric equation. Solve for theta in the domain 0 to 360. That is where theta lies for. 2, the cosine of 2 theta equals to negative 0.7071. Look at this. The first thing we do is to remain with cosine of 2 theta equivalent to, we divide it through by 2. So that negative 0.7071, when divided by 2, it becomes negative 0.35355. 35355. Yeah. So we are having this. Let's get a certain acute angle x. A certain angle x, which will be given by the cos inverse of 0.35355. Acute angle x becomes it becomes 69.295, which is 69.30. 9.30, sorry, not 330. Yeah, 69.30. So we are going to deal with an acute angle, which is equivalent to 69.30. 69.30. But now, where do we want this particular angle? In the quadrant where cosines are negative. So where are cosines negative? Look at the unit circle. In the first quadrant, all trigonometric ratios are positive. Sines alone in the second. Tangents alone in the third. Cosines alone in the fourth. Therefore, we need an angle of 69.3 in the quadrants where cosines are negative. Where are cosines negative? In the second, and also in the third. So the angle in the second will be identified as, the angle here will be given by 180 minus x, but at this point, we'll get it as 180 plus x. If we wanted it at this fourth quadrant, it would have been 360 minus the acute angle, but we want it in the second and in the third. Therefore, the values of 2 theta are going to be, 180 minus 69.3, and that is 110.7. Again, in the third quadrant, it shall be 180 plus 69.3 to 49.3. degrees. Those are the first 2 angles. But now we're supposed to tell ourselves, in case we make a complete cycle by adding 360 to each of these angles, we will still get the same trigonometric ratio. Therefore, 110.7 when we add 360, the angle, which is 470.7, will just behave the same as 110. And again, when we take 249, 249, yeah, 249.3, and we add 360, it will still behave the same, 609.3. We can even proceed to, we take 470.3 and we add 360, we get 830.3. It will still behave the same. Therefore, if we continue adding 360, we are getting other possible angles, which will behave the same as 2 theta. But now, theta itself now will be given by, when we divide each value here by 2. So 110.7 over 2. This is 55.35. And we have 249.3 over 2. This gives us 224.65. 124.65. 124.65. When we take the next angle, which is 470.7 divided by 2, this is giving us 235.35. When we take 609.3 divided by 2, I'm getting a 304.65 degrees. Then finally, when I take 830.3 divided by 2, I'm getting 415, which is beyond the domain provided. So this one will take us beyond the provided domain. So we stick to the first 4 possible angles because of the domain which has been provided. Yeah, so that is how we work it out. Remember to comment. Remember to share, like our video, subscribe to the platform. Yeah, please invite friends to this broadcast. Number 8. Yeah, number 8. Determine the possible values of x for which the matrix 2x, 12, 6x is a singular matrix. What is a singular matrix? Singular matrix is a matrix which has no inverse. And a matrix to have no inverse means that it has a determinant which is equivalent to 0. A singular matrix, listen to this, a singular matrix has no inverse. To have no inverse translates to a determinant being equivalent to 0. So if the date is 0, now we can get the possible values of x. So how do we get determinant? The product of elements in the main diagonal minus product of elements in the other diagonal. So we talk of 2x by x minus 6 by 12 should give us 0. What is this? 2x squared minus 72 should give us 0. Yeah, minus 72 should give us a 0. Is that true? Yeah. So we expect 2 values of x. We expect 2 values of x. And we can even say this, when 2 is factored out, we'll have x squared minus 36 being equal to 0. Therefore, x squared equals to 36. Because 2 equals to 0, that one cancels out. So the value of x will be the root of 36. And we know that the square root of 36 can either be 6 or -6. So these are the possible values of x for this particular problem. If the vector A, which is 1, 2, 3, and vector B, which is 4, -4, 6, find the magnitude of 3A plus half B. 3A plus half B. So this becomes 3, 6, 9 plus 2, -2. We are multiplying by half, 3. So this becomes 5, 4, 12. 5, 4, 12. So to get magnitude, it means now I have to take 5 squared plus 4 squared plus 12 squared. Then I obtain the square roots. 5 squared plus 4 squared plus 12 squared. Then I take square roots. Square root of 185. That is already correct because we have not been advised to any significant figures or any decimal places. But now it's good we work it out. That will be 13.60. 13.60 units. So that is it. Check here, number 10. As I remind you about the airtime program here, just go to your M-Pesa, Lipa na M-Pesa, the pay bill number 737356, then the account number is the phone number that you want it to receive airtime. It can even be the phone number of a friend, a parent, a child. Just buy them airtime, buy yourself airtime by putting the phone number as the account. Then now you proceed to the amount, complete your transaction. Airtime shall reflect instantly. Okay, number 10. The figure below shows a circle center O, AB, and PQ are chords which are intersecting externally at a point C. You can see C at this particular point. Then we are told that AB equals to 9, PQ 5, and also QC equals to 4. Find the length BC. This is our unknown BC. We are supposed to know that when chords are intersecting externally, like in this case, if we take the total length AC and we multiply it by the outer portion BC, we will get the same as when we take the other chord PC, the whole of it, and we multiply by the outer portion QC. Therefore, AC is going to be 9 plus X multiplied by BC, which is X. This will be the same as PC, which is equal to 5 plus 4, 9, multiplied by the outer portion, which is 4. Therefore, 9x plus x squared equals to 36. Yeah, equals to 36. So can we solve this one? And we are free to use any method, by the way. We are free to use any method. So starting with the x squared plus 9x, we can add a constant here so that we add the same constant to 36 to make the left-hand side a perfect square. How do we get the constant C? How do we get the constant C to make the left-hand side a perfect square? Should be given by b over 2 squared. So 9 over 2 squared becomes 81 out of 4. So we are adding 81 over 4. X squared plus 9x plus 81 over 4 equals to 36 plus 81 over 4. So let's talk about now factorizing the left-hand side. Factorizing a perfect square means taking the square root of this part, which is x, the sign which follows, which is a plus, the square root of the constant, which is 9 over 2 squared, equals to 36 plus 81 over 4. This will be 56 and a quarter. Yeah, so we can take square root of both sides. Let me use the space on my left. Square root of both sides means x plus 9 over 2 equals to plus or minus square root, which is 7.5. 7.5 or 7.5. So I can get the value of x now by taking 7.5 minus 4.5 or negative 7.5 minus 4.5. See the first value of x. When I subtract 4.5, I'm getting exactly 3. X equals to 3 or x equals to 7.5 and 4.5, negative 12. Now that we are dealing with length, we cannot entertain a negative length. So the value of x is concluded to be 3. The value of x is concluded to be 3. I've used the completing square method to solve, and I can see a question in number 11 demanding the completing square method to be used again. So for us to use the completing square method, we have to divide through by 2. We divide through by 2 such that x squared minus half x minus 18 equals to 0. So x squared minus half x equals to positive 18, but we are supposed to add a constant here. Remember, this is our third time in this paper to use the completing square method. So I don't expect now any follower of this paper to come out without knowing how to deal with completing the square method. All right. So at this point now we get C. And how do we get C? C should be given by b over 2 squared. What is b? B is negative half. We divide it by 2, then we square. This will be negative 1 over 4 squared, which is 1 out of 16. Therefore, I will talk about x squared minus half x plus 1 over 16 equals to 18, also plus 1 over 16. 1 over 16. So now, allow me to do what we call factorizing. Factorizing the left-hand side, which is a perfect square. I need the square root of this part, which is x, the sign which follows, which is a minus, the square root of the constant, which is 1 over 4 squared, equals to 18 and 1 over 16. 18 and 1 over 16. At that point, we can now take what we call square root of both sides. X minus a quarter equals to plus or minus. When I take square root of the right-hand side, I'm getting 4 and a quarter. 4 and a quarter. The right-hand side is 4 and a quarter. So can we get the value of x by taking 4 and a quarter plus a quarter, or x becoming -4 and a quarter. Let me express it in a clean way. Or the other value of x can become -4 and a quarter plus a quarter. In the first case, 4 and a quarter plus a quarter becomes 4.5. Now, in the second case, whereby we have -4 and a quarter, then we add a quarter, it will become exactly -4. Yeah, exactly -4. Exactly -4. So that is it. We proceed now to number 12, which is on commercial arithmetics. Remember, ladies and gentlemen, to subscribe to this platform. Remember to share the link with friends. Invite people, comment, like, and do everything to this platform. This is your best for your best. Number 12. A businessman obtained a loan of 450,000 Kenya shillings from a bank to buy a matatu valued at the same amount. The bank charges interest at the rate of 24% per annum, 24% per annum, compounded quarterly. Calculate the total amount of money the businessman paid to clear the loan in 2 years. Give your answer to the nearest Kenya shilling. We know that the amount is usually given by principal 1 plus rate over 100 raised to n. So the principal is the amount borrowed. This is equal to 450,000 into 1, which is a constant, plus the rate. Now, the rate here per annum, it is 24%, which means in a quarter a year, we have to divide by 4, 6%. If per annum, this one, students are supposed to be very careful again. If it is 24% per annum, and that is why I have underlined 24% per annum, but now we are compounding quarterly, then every a quarter will take 6. But now, how many quarters will be there in 2 years? So n will not be 2. N is going to be 2 years, and each year is having 4 quarters. So it will become 8 at that point. So now we go to the calculator and talk about 1 plus 6 over 100. Then this now is what we are raising to power 8. After this, we multiply by 450,000. So I'm getting 717 to 31.63 Kenya shillings. But remember, we've been advised to give it to the nearest Kenya shillings. So 717,232 Kenya shillings. So that is how we supposed to work it out. Yeah, that's how we're supposed to work it out. Number 13 on sequences and series. 13 on sequences and series. The 5th and 10th terms of an arithmetic progression are 18 and -2 respectively. Find the first term and the common difference of the same, of course. 5th term, so this is about nth term. In arithmetic sequences, how do we get nth term? Nth term is given by a plus n minus 1 multiplied by b. So the 5th term is known to be 18. This is equal to first term unknown plus n. Since it is 5th term, n is 5. So 5 minus 1 becomes 4 times the value of the common difference, which is unknown. Again, we have the 10th term, which is negative 2, equals to first term unknown. Being 10th term, it will be 10 minus 1, 9d, which is equal to 2. Now that we have the two equations, we can solve them simultaneously. Allow me use the elimination method now, whereby I subtract corresponding terms downwards, such that it's the value of A, it will simplify. I'm using automatically the elimination because I've already seen that the coefficients of A are 1 in both equations. So now we can subtract 18 minus negative 2, making it 20. Then 4D minus 9, making it a negative 5D. So the value of D becomes negative 4. That is when you divide it through. The value of D becomes negative 4. And even before we found it as a negative D, it is so automatic that it will be negative, because we can see the 5th term is already greater than the 10th term. That is to mean that the sequence is decreasing. So it has a negative common difference, a negative common difference. Okay. Substitute in equation 1, 18 equals to A plus 4 into negative 4, the value of D. So now we can talk about 18 equals to A minus 16. So that the first term becomes 18 plus 16, becoming 34. So the first term is 34. The common difference is negative 4. Yeah, that is it. We are almost winding up. Number 14 now, out of 16 questions. The perimeter of a triangular field is 120. Two of the sides are 21 and also 40. Calculate the largest angle of the field. So we are having a triangular field this way. Let me draw it first, just a sketch. The other side here, which is not now some other two sides here. Like that. So now we are talking about 21 and 40. 21, 40. Then now the unknown side. If the perimeter is 120, we have to subtract the known sides, 40 and 120, giving us 59. Giving us 59. Then about these angles, we are supposed to know that the largest angle is usually opposite to the longest side. So I've named the angles. We can also name the sides, whereby this becomes A, this one becomes B, this one becomes C. Yeah. The largest angle is usually bound by the shortest sides, or it is usually opposite to the longer side. Okay, with that information now, we know that we want the angle at this point. You can also work out all the angles, but if you have that information, you will go straight to your answer. If you have that information, you'll just go straight to your answer. So let me go to the cosine rule, which says that it's now trigonometry 2, which says that if we take A, we square, we will get B squared, C squared minus 2AB cosine of the angle at A. Therefore, A squared is 59 squared equals to B squared 40 squared, C squared 21 squared, minus 2 multiplied by 21 by 40 cosine of unknown angle at A. Yeah, that is how we apply the cosine rule. With that in our mind, can we talk about 59 squared, which is a 3481, equals to 40 squared plus 21 squared, which is 2041, minus 2 multiplied by 21 by 40. This becomes 1680. Yeah, 1680 cosine of the angle at A. So that now 3481, we subtract 2041. This is giving me 1440, equivalent to negative 1680, the cosine of A. So for me to remain with the cosine of A, I'm supposed to divide 1440 by 1680, which is negative. So I'm getting negative 0.8571. So how am I going to get the value of A? I need the cos inverse of negative 0.8571. To me, this is an angle in the second quadrant where cosines are negative. And this becomes 148.997. 997. Yeah, that is it. 997. So that is how we work it out. Look at number 15 towards the end of the paper, or the end of the section 1. Given that A is in between 5 and 8 and B lies between 2 and 3, find the limits of. Find the limits of. We are again back to errors and approximations. Errors and approximations, where we are supposed to know that for us to get the limits, we are not finding percentage error, we're just finding the limits. So we need the maximum value and the minimum value. That is what we call the limits. So the maximum value of this expression, we need to first get the maximum value. So we need maximum quotient. It's a division. So we need maximum quotient. How do we get maximum quotient? By ensuring that we need maximum numerator, but we use minimum denominator. So how do we ensure that the numerator is maximum? How do we ensure that the numerator is maximum? Numerator will be maximized when we take the upper limits of A. Okay, it's a difference. Sorry, it's a difference. The numerator is a difference. So how do we ensure that difference is, there is errors inside errors. We are dealing with quotient and also we are dealing with difference. So we are saying that for us to get maximum quotient, we need the bigger numerator divided by the smallest denominator possible. Smallest possible denominator. So I can now talk about A minus B to give me maximum. So I need 8, but I subtract the least value for B for me to get a maximum difference. Then I divide by, I need the smallest denominator, which is a sum. So the smallest sum involves the lower limits, both lower limits. So 5 and 2. 5 and 2. So at this point, I'll be talking about 6 out of 7. That is the maximum possible quotient. For me to get minimum quotient, I need minimum numerator, and I divide it by maximum denominator. Yeah, divide it by maximum denominator. For minimum numerator now, for me to get minimum numerator, which is a difference, and I want it to be minimum, then I'm supposed to pick the smallest value at A, but I subtract the biggest value for B. So 5 minus 3 divided by, for me to get maximum denominator, which is a sum, I'm supposed to get upper limits. 8 and 3 added. 8 and 3 added. So this will be 2 out of 11. So the limits are the biggest value or the smallest value, 2 over 11, all the way to 6 out of 7, the largest possible. So these are the two limits. And finally, we got a number 16 here, which is on chords and tangents. The diagram below shows a circle center O. PQ is a tangent to the circle at C. PQ is a tangent to the circle at C, just as you can see. Then we are told that the angle DCQ is 46, already indicated here in the diagram. And the other angle, which is given, is a BSC 27, indicated. So from that now, we are taught to find, giving reasons, the size of the following angles. The first angle we have to find is CAD, then BDOB. So the angle at A and the angle at A, that is a CAD, this one, and also the angle DBO, center O, DBO. Yeah, DBO. So we can work out some angles here very fast. Remember, we have been advised to give reasons when working out. So when I see angle 27, the angle of 27, it has been produced by the same chord, that produces the angle here. The chord BC projects an angle of 27 at the circumference and also an angle at B. So which means this is also 27, yeah, that way. That's how we fill a few angles. So let us fill several. We will get back to the specific angles that we need to calculate, but for now, let us just fill them generally. Let's fill them generally. Again, there's something that we are supposed to understand. That we have an angle which is made by a tangent and a chord CD of 46. The same chord is supposed to produce an angle of 46, because we usually say that angle made by a chord and a tangent is the same as the angle made by the same chord in the alternate segment. Therefore, if CD and a tangent are making 46, then CD should produce an equivalent angle in the alternate segment, 46. So CAD equals to 46 degrees. angle made at the alternate segment. It should be the same as the angle made by the same chord and the tangent. That is good. Now, if we are to look at other angles, which might be equivalent to 46, then we would say that CD is also the one produces the angle here. Angles produced by the same chord are usually equal. So that is 46. Again, we're supposed to know something here, that the chord which produces 27, you see, AO and OB. OA and OB are both D, so they should give us 27s at this point. So 27 and 27 must be equal, like that, yeah. 27, 27, 27, 27. Okay, there are other many angles whose value can be found. For example, agree with me that having the angle of 47, having the angle of 27 top here means that at the center we will have a double angle. Angle subtended at the center is double the angle at the circumference by the same chord. So BC produces 27 at the circumference. So BC is supposed to produce the angle at the center as 54. Yeah, that way, as 54. Again, we're supposed to know that the line AC is passing through the center. So it is a diameter. It is a diameter. Being a diameter, we should know that a diameter produces 90 degrees. If a diameter produces 90 degrees, then the whole of the angle here should be 90. The whole of the angle ABC should be 90 because it is subtended by the diameter. Diameter produces 90 at the circumference. So to get the remaining angle here, the angle we want here, it should be 90 minus 27 and 46. 90 minus 27 and 46, giving us 17 degrees. So the angle here is 17 degrees. Reason being, angle subtended by diameter is usually 90. Angle subtended by diameter is usually 90. So we are done going through the paper. It was such interesting. Thank you for being part of this program. Subscribe and share with friends. Thank you so much.